Hey, welcome guys on location. We are actually in my classroom. Oh, the wonder. Okay, so we are in 8.3 starting off, and this section is going to be a little bit more confusing. I think, hopefully so far, Chapter 8 has not been too bad with confidence interval. But 8.3 adds just a little bit more niche into complication. But today's lesson should be fine. It's lesson 2 that you should be kind of sweating over. Okay, so estimating the population mean. So 8.2 is all about estimating the population proportion. Now we're doing mean, right? All right, so we should be thinking, kind of switching gears here. We've got some different rules, a couple different things. Guess what our one sample z interval looks like for a population mean? What do you think it would be? All right, just think about it. Pause it if you need to. All right, write it down. I bet you guys know the formula already. It is going to be my best guess, right? This is the symbol for mean, plus or minus your critical value times your standard deviation. But, well, remember, your standard deviation looks a little different for means. Standard deviation for means is your standard deviation divided by your sample size. Sample size of n. Like that. All right? So, remember before we were 8.2, it looked like this, right? It was my p hat plus or minus my critical value times this one's standard deviation, which is the square root of p times 1 minus p all over n. Right? Okay. Well, this one we're going to be using the bottom one. All right? Cool. Cool beans, right? Yay! We already know what we're doing, hopefully. All right, let's move on. Number 8.3. So here we go. Over the past week, juniors of all shapes and sizes took the ACT. Mr. Sheevy took a simple random sample of 32 students and found that the average score was 8.9. Now, this is from my sample, so this is a best guess. Doesn't mean it's accurate, right? Okay. When asked, Mrs. Rudkin said that the population standard deviation, so this is the population deviation, was actually 4.4. Remember population. So that is the actual deviation. Okay, that's not a guess. With a 95% confidence, find the interval of Craig's true ACT average score. Oh. All right. Well, we're going to, first of all, if this was an actual AP question, I would do my state. All right. And for time's sake, ladies and gentlemen, I have to keep it moving. Keep her moving. And any Manitowoc Minute fans, keep her moving. So I'm going to state what would I do. So you can write it down if you want to, but I would say I will perform a one sample mean z interval test to find 95% confident to find the interval of Craig's true ACT average score. Basically, you're kind of repeating this sucker down here. All right, that would be my state. Do not do this and put an arrow on your test, by the way. All right? Don't do it. I know I'm doing it for time's sake. Plan. And I know you guys don't have very much room either on your paper I didn't give you. Plan. Well, is it normal? Is it random? Right? Oh my goodness. My pen is not working good. Is it independent? Indy. All right. And like for sake of time, I can't write all these things out. But is it normal, first of all? Well, what's a normal test? What's the normal test for a mean? More than 30, right? Do I have over 30 students? And yes, I do. So, yes. Check. All right, don't do this on your test either. You need to explain out why it's normal. Is it random? And I would say yes. It's stated a simple random sample. And is it independent? All right, and how do we know if things are independent? Well, if we take less than 10% of the population of juniors is over 320 at Craig. So we would say yes, because there's more than 320 juniors at Craig. Okay, there's around 400. Cool beans. So that's my plan. Now let's go to dual. Do. And literally what I would do is my best guess, which would be 18.9, which is not very, it's not accurate, right? That's just from 32 people. That's what I found was their average ACT score. Times a critical value of 95%. Well, 95% confidence interval would be a 1.96er. You should almost have that memorized by now. Times my standard deviation. And the standard deviation, obviously, since I sampled 32, is going to be smaller than a standard deviation of just 1. So it's going to be 4.4 divided by the square root of 32. That doesn't look like a 3. There we go. That kind of looks like a 32. All right. There we go. You guys cool with that? Now, at this point, you can leave it. And you can put it in your calculator. So I'm going to show you how to put this in your calculator. Full screen. Woo, boy, the lighting's better. All right, here we go. So I'm going to go to Stat. Go over to Tests. And here's the kicker, guys. This is not a proportion, so you're not looking for proportion. And you're looking for an interval. Now, right now, I just want the plain old Z interval. It's not a proportion, so it's a Z interval. Boom. Okay? And then, do we have actually data? Did we put data into L1 or L2? And no, we did not. So we are going to use the stats, and the stats was, what was our standard deviation? Was it 4.4? Nope. I think it's 4.4. Our mean, I believe, was 18.9. Our sample size, which is N, is 32. And we want to be 95% confident. We'll hit enter, and we'll get our interval. Okay? All right, if all my stuff was right. Okay, let's see. Yeah, that's close enough. All right, so my interval is from 17.38 roughly to 20.42 roughly. Okay? And then in my conclusion, I would say I am 95% confident that I've captured the true mean of an ACT juniors mean score is somewhere between a 17.38 to a 20.42. We'll see in a little bit. Huh? All right. There we go. That is how we would do it. Not too bad, right? Not too shabby. All right. So far, we know how to estimate the population mean if we are given a population standard deviation. Here's another situation. We took a simple random sample of 300 men and asked them how they could cut their hair. The average from our sample was this. Now remember, that is how often they cut their hair. That is the average amount of time it takes before a man gets their hair cut of the 300. And the population, somehow we figured out what the population was. All right, and hopefully at this point in time in the game, you're going to realize what next lesson is going to be about. Because if I've got a sample and I'm trying to estimate the actual mean, right? I'm trying to find that. I probably don't know the actual standard deviation either. But we're going to go with it. All right. In fact, I don't even like doing this necessarily, but every once in a while there's like one question on the test. If the population standard deviation is 0.3, construct a 95% confidence interval. Okay, so I do my state, my plan, my do, conclude. Obviously, I don't have time for that, so I'm going to just go 1.6 is my best guess, plus or minus. I want to be 95% confident, so I'm going to say 1.96. times that by my standard deviation of 0.3 divided by, how many people did we sample? 300. Wow. La la la. Cool. Cool beans. All right. And if I do that in my calculator, I'll get my interval. I'll be right back. All right, so I've just typed it in my calculator. That is what it should look like. This is under Z interval. It should be standard deviation 0.3, a mean of 1.6, sample size of 300, confidence levels 95%. Press enter, and there is my interval. All right, so like I said, feel free to pause whenever you need to. But I got basically a 1.56. 66 to 1.63. All right. So in conclusion, I am 95% confident I have captured the true average that it takes a man to get his hair cut is somewhere between 1.566 months and 1.63 months. Now remember, that's not what every man, because obviously some men have grown their hair out long, but the average time it takes a man would be somewhere between there. I'm 95% confident. Okay? All right, let's move on. We got one more scenario. Okay? I'll be right back. All right, so here's the last question of the day. Researchers would like to estimate the mean cholesterol level of a particular variety of monkey that is often used in laboratory experiments. Okay, so they're trying to estimate what the actual mean is. They would like their estimate to be within 1 milligram, so they want to be pretty sure. They basically means they want to be off only by 1 milligram, okay, plus or minus, okay? So, we want to be 95% confident, and the standard deviation is here. All right, so remember, we want this plus or minus, basically. We don't know what this is, right? But we want the plus or minus to be we just want it to be 1 milligram. That's what we want. So this is that scenario we had with percentages. We did this, but I think it's a little easier this time. We want 1 milligram to equal, well, my critical value. Remember, my critical value is over here, and my standard deviation is over here. Okay, so my critical value for 95% confident is going to be 1.96. And my standard deviation is going to be 5 divided by, and I don't know how many people I should sample. That's the question, right? Because depending on how many I sample, I do better. All right. So does that make sense? I want this wiggle room to be 1, which is this rot here. All right. So I need to do some algebra. Okay. So just it's slightly different than the last one because it's a different formula. But I'm just going to do algebra here. Divide by 1.96. All right, so I got 1 divided by 1.96, and I get something like 0.5102. And I'm going to keep this all in my calculator because I want to be extremely accurate. I have 5 then over the square root of n. All right, and this time I might actually multiply by the square root of n. Multiply by the square root of n just to knock this sucker out of the bottom. And then I'm going to bring this guy over by dividing it by 0.5102. So I'm going to divide this by 0.5102. Okay, almost running out of time here. I got the square root of n equals 5 divided by that rot, and I'm putting that whole number in there, which equals something close to 9.80. And then I'm just going to square both sides. All right, now obviously I'm going to have an answer of 96.04. Now, I want it to be within 1. So if I round down, it's going to be slightly bigger than 1. So I want to round up to 97 monkeys. All right, have a great day, guys.